Hey guys, welcome to another video. So today, another video in the 100 series, the 4-unit extension to integration questions that I'll do. Today's two questions come from the Coroneos 100, where I'm actually going to do question 100, right, as my second question, which I think is pretty cool. Now, before I begin, as always, guys, if you like these videos, subscribe to the channel and tell your friends and like the video when you're done. All right, let's dive right in now. Before we actually dive into the questions, as per previous videos, if you want a copy of the Coroneos or the Next Education 100, please email us at info@nexteducation.com.au. Right, guys, let's dive right in now. First one, not too bad, not too hard, but I just wanted to draw out that there are two ways to do this, right? I always say to my students, whenever there's a fraction and you're integrating and it's a polynomial, right? Denominator's highest power is x squared. The highest power upstairs is equal or above. It was equal if it was an x squared. In this case, it's an x cubed. There's two ways to do it. You can either use long division, right? Or you use algebra manipulation. Algebra manipulation is faster and better, right? Sometimes. Sometimes division of polynomials is better, but most of the times it's better to manipulate. And I'll show you what I mean by that, guys. So algebra manipulation. So if I had x squared plus 1, right now I have x cubed. The question is always, right, what do I add or minus here so that I can simplify this fraction, right? So I can simplify this fraction. So in this case, if you think about it, if I added 1, that won't do, right? Because it's x cubed. However, if I was smart about it, if I added x, right, x cubed plus x, when I split the fraction over here, right, if I split the fraction over here, right, I can factorize the x from the top and it'll be x squared plus 1. That will cancel out with the bottom and make it integratable. So because I'm adding x, I have to minus x as well to sort of neutralize that addition, right? And then I'm going to break the fraction there, right? Split the fraction into two parts. So it becomes like x cubed plus x over x squared plus 1, and then minus x over x squared plus 1. Great. Now, so from this part here, I can factorize the x, and from this, so factorize the x, brackets cancel out, and then I'm left with x. I can integrate that quite easily. For this section here, guys, that's what's that? That's ln, isn't it? Yeah. So basically, I need to reverse chain. I need the derivative on top, multiply that by a half. Right. So now, actually, can I take a step back? The pink highlight. If I factorize x out, right? That bit cancels out with that bit, and I'm left with x. So what you get is basically integral of x minus, now I'll put the half there, multiplied by 2x all over x squared plus 1, because that's ln, because if the function's downstairs, the derivative is now upstairs. Everything's integratable, guys. My final answer will be x squared on 2 minus a half ln x squared plus 1 plus c. And if you're amazing, you basically put them all on the same common denominator. X squared minus ln x squared plus 1 plus c. How's that? Pretty straightforward. Nothing too hard about that, guys. Let's move on. Now, next question is question 100, right? This is the 100, right? I love this question, right? There's a lot of technique in here for relating to trig that you need to know. I mean, when you look at this, first reaction to this, right? It says to yourself, maybe if I let this be the function, is a derivative in front? Short answer is no, because the derivative is at, what's that, 3, cos minus blah, 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 cos. That's not that. No. Second thing you can explore is maybe expand. And if you do expand, you get something sine squared with cos, something sine. You can't actually use u sub, can you? Right? You can't actually use u sub, right? But that's no fun. I'm looking at that, and you can use u sub, right? Okay, cool. I didn't do it by u sub. I did it by heavy technique. Okay, and maybe I'll do it. I'll do it with heavy technique. I'll do a u sub. See if I get the same answer. Now, with the heavy technique, right? You identify that. Everybody sort of knows that by now, right? That's sine double angle. The question is, do you know what this is, right? Yeah. So if you've done trig and on top of the trig game, right, You know that this is sine double angle. And if you were on top of your trig game, you actually identify this as sine 3 theta. Yeah, because if you think about sine 3 theta, right, the way you sort of expand it algebraically, right, you get this. Yeah, then you get like sine, 2 sine cos. Yeah. No, that's a lie. That's compound. So sine A cos B plus sine B cos A. Expand everything, so that's 2 sine cos plus sine. Now I want everything in terms of sine, right? So I'm going to use a cos one that has 1 minus 2 sine squares. Right, that becomes like 2 sine cos squared is now 1 minus sine squared. I'm going quickly because this expansion, hopefully you guys understand what I'm trying to do here. I'm just applying a few trig identities. And then guys, if you collect like terms, you got 2 sine plus sine, that's 3 sine. You got minus 2 sine squared, minus 2, that's minus 4 sine squared. Cube, sorry. And that's what that is, right? Now, do it this way first. It is complicated because I think actually U sub is actually quite surprisingly straightforward. But let's use this one first because it's actually quite nice to demonstrate, right? Just in case there's a question that needs this, right? Yep. So sine double, sine triple. Now, whenever you're in this situation, guys, products of sums, right? Whenever you have sine and the angles are different, right? Use products of sums. So now that the reference table has that in there, like back in like 2019 beyond, they didn't, right? This is what I'm talking about, right? Yeah. So basically, in this case, sine, we're talking this one here, right? Yeah. So replace it because I can't integrate sine 2 theta multiplied by sine 3 theta, right? However, I can integrate it when they're summed, right? Sine some angle plus sine some, I can do that, right? So using that, this becomes, all right, half 0 to pi 2 sine, now a plus b. Always, I say it to myself, because it's multiplicative, you can choose whichever one you want to be a and b, right? Always choose the bigger one to be a, right? And choose the smaller one to be b. Because you're going to be minusing it, you don't want negatives, right? So the formula says sine a minus b plus sine a plus b. Am I doing thetas? Yep. So that becomes half sine theta plus sine 5 theta. Yeah. So then half integrate sine, that's negative cos minus cos 5 theta on theta. No, on theta, on 5. Yeah. So now make it easier for yourself, guys. I don't know whether, for some reason, my students tell me that the teachers at school don't really talk about this much. But basically, if you can factorize a negative out, you can switch the limits, right? Because mathematically, if you sub in the limits now, it's like something minus something. But if you take out a negative, right, it flips it around, right? So you can actually take it out mathematically, make a reading positive before you sub things in. It just makes life a little bit easier. On 2, 0. Make sure I'm on the right track. Yep. Okay. Yep. Oh, have I used the wrong one? Sine, right? Oh, I did use the wrong one. Guys, it should be sine, it should be this one here. My apologies. Same concept, different calculation, right? So half cos minus cos. Okay, cool. Let's quickly fix that. Yeah, I'm sure you guys, when watching that, you were calling out for me to do that. So cos. You were cos. It's minus plus. Yeah, cool. So when I do that, quick fix, cos. That's a minus there as well. And so when I integrate cos, okay, it's actually better because like when I integrate cos, it's actually positive. So okay, makes things a little bit easier. So I don't have to do this separate line here. Sweet, let's fix that quickly. Integrate that sine minus sine 5 on 5. Good thing I checked. Okay, let's sub it all in. So half. So it'll be like sine pi on 2 minus sine 5 pi on 2, which actually happens to be like sine pi on 2 minus sine 0 minus sine 0, which is 0. So I don't really mind. That bit goes away. Sine pi on 2 is a half, so that becomes 1 minus 1/5. And so the answer was that 4/5 divided by half, so 2/5. Tick. Guys, this one's full of technique, right? If you did it this way. Now, I think, let me see. I'm hoping that I'm mistaken because the alternative just seems really easy, right? So if I expanded that question, 0.2, what am I going to get? I'm going to get, so going back to the original, I'll get what? 6 sine squared cos minus 8 sine 4 cos. Yeah, I actually think I can do this by u sub. All right, let's see. So I call it u sub. Some teachers just call it substitution. So if I go let u equal to sine du d theta equals to cos, which means du on cos is equal to d theta. So I'll be replacing that in here. Because there's limits, I'll change the limits. So when theta is pi on 2, u equals to sine pi 2, which is 1. When theta is 0, u is 0. So I'll be subbing that over here. And I'll replace each element of u into the signs. Interesting. So then I get 0, 1, 6 u squared. Now I can factorize the cos out, right? Because the cos actually, let's factorize the cos here. Because it cancels out with the, when I sub in the pink, 6 u squared minus 8 u4 multiplied by du on cos. Okay, that gives me 6 u3 3 minus 8 u5 5 1 0. So that's 2u squared, right? So when I sub in 2 1 squared minus 8 1 5 5 minus 0 minus 0, right? Now 2 minus 8 on 5, that is 2 on 5. Okay, get the same answer. Sweet. Right. So guys, very boring but very effective u sub method to do that as well. That was question 100. 2 questions from the 100 from Coroneos. Hopefully that was okay, guys. If you like that, subscribe to the channel, tell your friends, and like the video. See you at the next one. Thank you very much.